Hi, Simon. How are you doing?
I'm great, thank you. How are you?
I'm great, thank you. Yes, looking forward to hearing your talk. I wanted to learn a bit more about you first, though. Where did you learn to program?
I ended up teaching myself HTML from a book when I was about 13 years old, before we even had an internet connection. That's how keen I was.
That must have been an absolute nightmare trying to teach yourself HTML with no internet connection.
Yeah, there were only a few pages in the book that covered HTML as well.
Yeah, I tell you what, the kids nowadays, they don't know how good they've got it, do they?
Exactly. It's pretty amazing.
And would you say you have a highlight of your web development career?
I think probably one of the highlights is when the singer Tom York from Radiohead tweeted about a website that me and a few friends had built that really felt like validation.
Oh, that really is the pinnacle of any web developer's career, I think. So yeah, that's brilliant. That's fantastic. Right. Well, Simon, I'm going to hand over to you now with improving your applications with AbortController.
Brilliant. Thanks, Katie. Okay, let's get this going. So, hi everyone. Today we're going to be looking at how you can improve your applications with AbortController. If you want to grab the slides or any of the code from this talk, it's on my website, simonplen.com/nodecomp2021. But first, a little bit about me. So I'm an independent Node.js consultant and educator. This means that I help companies and development teams use Node.js to ship great products that grow their businesses. I also help developers level up with Node.js through articles on my blog. And I'm the author of Express API Validation Essentials. It's a book that introduces a complete API validation strategy that you can start applying in your Express applications today. If you're using Express, I highly recommend you check it out. And you can find me in the normal places like Twitter and GitHub. Now let's get into it. What's on the menu today? So in a moment, I'm going to introduce you to my fictional client, Ice Cream Corp. I'm going to tell you about the problems they're having with their Node.js services. And then we're going to start to look at how we can solve them. We're going to try some performance testing as a way of isolating the issues that their services are having. And then we're going to look at a previous attempt that their development team has made to improve the menu service. We'll then introduce the Ice Cream Corp development team to the Abort API. And we'll use it in Menu Service v3 to improve the menu service. And lastly, we'll wrap up taking a look at the support for the Abort API in Node.js. So Ice Cream Corp have some serious problems. They've got a pretty common service-based architecture. So for the millions of people around the world who are trying to find the Ice Cream Corp menus, they're going to their website. And that is a front-end JavaScript application, which loads in the user's browser, and it makes a request, an HTTP request, to a menu service. This provides all the delicious flavors that Ice Cream Corp have to offer. And this menu service also calls a stock service because Ice Cream Corp don't want to be showing ice creams which are out of stock to their customers. And the stock service runs SQL queries against a database to get that stock data. It sends it back to the menu service, which is then able to serve data back to the front-end application, and users can then view the Ice Cream Corp menu. Now, the problem we've got at Ice Cream Corp is that the stock service, despite being a business-critical API, it's a bit unloved and a bit unmaintained. So some of the SQL queries that it runs execute very slowly on the database server. This means that the response times from the stock service become very unpredictable. And as a result, the menu service then is also unpredictable because it's waiting for these responses to come back. So Ice Cream Corp want us to help the team which runs the menu service see if they can improve things. Now we're going to take a look at the service, the stock service and the code for it. So this is an HTTP server in Node.js built with the Fastify framework. It has a single endpoint for retrieving stock. Now, normally that would be coming from a database, but in this case, it's here in an array for this example. And we've got all the delicious ice cream flavors and also their stock amounts. Now, in order to simulate SQL queries that are running slowly, we're creating a random delay. So this is between 0 and 10 seconds delay. And once that delay has elapsed, we will then send back the stock data in a response. Now we're going to take a look at the menu service and how it is now. So we can see here that the menu service has a make request function, and that's using the popular HTTP library node fetch. It's requesting data and then passing the response body as JSON and returning that. We're using it here in the menu endpoint, which the menu service exposes. And we are then calling the stock service with the make request function. And then sending it back to our client application running in users' browsers. So this is a fairly common kind of service-to-service HTTP request pattern. Now let's take a look in the terminal at how this is behaving. So we can see here we have the menu service running, and we're going to run the script, which will use curl to send some requests to it. And we can see the kind of behavior we've described. So it's actually running in the background, making a request to the stock service. And we can see here the delay on that request was well over 7 seconds, which is really, really bad. So the slow issues that the stock service are having are affecting things upstream in our menu service. And all these requests are very unpredictable response times. So it's not hard to see why the menu service is having problems. Now, in terms of actually figuring out what's wrong with the menu service and how we can potentially improve it, we're going to try some performance testing. And this will allow us to help the developers at Ice Cream Corp understand the behavior of the menu service. We're going to use two tools. One of them is called AutoCannon, and it allows us to send lots of requests to the menu service and simulate a really high load of traffic. And we're also going to use Clinic.js, which allows us to profile our menu service and actually see how it's behaving and what's going on with it. Often people will ask, what does good look like for load test and profiling results? And the honest answer is it's very variable, but we can actually use these tools to establish what's going on and figure out a baseline and then look at how we can improve things from there. So when we run AutoCannon against the menu service v1, we can see here that the average response time is really, really slow. As we kind of saw from the script that was running in the terminal, it's all over the place. And the average response time is about 4.9 seconds. So it's really not a great situation for most users and who are getting very unpredictable response times. And bearing in mind that there is a front-end JavaScript application calling this, it's going to be really slow and they're going to have a bad experience. And who knows, they may never come back to Ice Cream Corp to get ice cream again. Also, the response time, as well as the response time, the request per second is pretty low, just over 19 requests per second. So things are really not in a great situation, but we know this is because of the stock service behavior and because that is running unpredictably. We can see here when we look at the Clinic.js doctor profile that CPU usage for the menu service is kind of all over the place. It's spiking up and down. Sometimes it's quite low. It's really not very consistent. And that suggests that the Node.js event loop is actually waiting for a lot of I/O operations. And the I/O operation in this case is all the HTTP requests that we're making to the stock service. You can then see in the bottom right-hand corner the active handles. And these active handles are representation effectively of underlying IO operations. So that's the HTTP requests. And it's reasonably high, but fairly stable, which is what we'd expect for the level of traffic we're putting through with AutoCannon. Now, the big question, how can we improve the menu service? We could try bringing up a V2 and refactoring what we have. Now, it turns out that the Ice Cream Corp developers have actually already tried improving it. So let's take a look at the changes they've made. And we can see here, we've got the make request method that we saw previously, but we've also got a new timeout function. And this timeout function is actually returning a promise. And we'll see why in just a moment. Then down here in our menu endpoint, the change here from just awaiting make request is that we're now using promise.race. And this is racing two promises against each other. So promise.race returns a promise, and it will be fulfilled when either make request or timeout have their promises reject or resolve. And what that means then is that if we're making this request, that starts first, or at the same time rather as the timeout. And when the timeout kicks off, it returns a new promise, and that's got a set timeout inside of it. And after the set timeout has run for whatever period we specify, which is 1,000 milliseconds, 1 second, it will then reject with a new error. So the idea is that if the stock service request is taking longer than 1 second, the timeout will kick in, an error will come from that rejection, and we'll be able to send back an error response. And it gives some kind of predictability to the service and to what we're doing. So let's actually run menu service v2 and see how that behaves. So we can see now that we're actually getting responses back much faster. They're still slow, but 1,000 milliseconds. So we've got some kind of control over what's happening. And in this case, all of those requests took longer than 1 second. So we can then flip back and take a look at what that looks like under load. And the load that we can see here is definitely an improvement. So average response time is under 1 second. So not great, but something much more predictable. So we can say that the menu service will always respond in under 1 second. And we're getting much more requests through the service, over 100 requests. Now, the downside is that although we've got this predictability, only a handful of requests have actually succeeded. You can see down the bottom here that out of the 6,000 requests, over 5,500 of them actually were an error response. So things are better in terms of overall performance. We have more predictability, but we obviously can't solve the problems of the stock service just by making these changes. Now, things look better from these AutoCannon results, but if we look at the Clinic.js doctor results, they show a different story. So the CPU usage is still very spiky, and actually, rather than improving things, we've actually managed to almost triple the number of active handles at any one time. And this is because we've not actually canceled the HTTP request. If we head back to the code, we'll see that this error message here is actually a lie. There's no canceling happening in the service. The timeout occurs, the promise ends up being rejected with this error, but there is nothing happening to tell the request to actually stop, to cancel. And we can prove that by running our server again, and we can add a console.log of the response data. And what we're going to expect to see is that we'll send back an error response from the menu service, but actually the request will still be running in the background, the slow request, and that request won't actually get canceled. So if we then start the menu service again, and we do a curl request against it with the shell script. We'll see that these requests are all canceling. However, we're still getting the responses back here. And that's really not great. If we're sending back a response in 1 second saying there's been an error, but some of these requests are taking over 8-9 seconds. So that's still using all the system resources and all the network resources. And that's why we've seen that terrible result in the Connect.js results. So this is an anti-pattern. Unfortunately, I've seen it implemented in real Node.js services, and you should definitely avoid it. So what now? Well, we're going to introduce the developers at Ice Cream Corp to something which can help. We're going to use the Abort API. But first, let's learn about what it is. It's a JavaScript API, which is designed to help us abort asynchronous operations. It has 2 classes, an AbortController and Abort Signal class. And these 2 classes work together to form the Abort API. You can see, I'm going to switch back to the slides so you can see them. And you can see over here that when we're creating a new AbortController instance, we have an AbortController instance which has an abort method. And it also has a signal property. And the signal property has an the signal property has an abort signal instance, which has an aborted property on it, which is a Boolean, which is false by default. And the idea is that when we call the abort method on our AbortController instance, it will change the aborted property to true on the abort signal instance, and then it will proceed to actually dispatch an event. And we can see that here in this code. So in this code, we're creating a new AbortController. We're, for convenience, assigning the signal from that AbortController to a variable. And then we're adding an event listener to the signal. And we're able to do this because the abort signal class extends from the event target class, which allows us to dispatch events. And so under the hood, this is all event-based. And that's why we're listening for the abort event here. And then once that abort event happens and is dispatched from the abort signal, we'll be able to log out this message. And we will only want this to happen once. And finally, we'll call the controller abort method, and that will make all of that happen. It will dispatch that event from the abort signal, change the aborted property to true. And then we'll be able to run that handler and log out the message. Now, support for the API is really good. It originally originated in the web platform, and Microsoft Edge 16 was the first browser to implement it. Now all major browsers support it, and stable support has existed in Node.js since v15.4, which was released in December 2020. We'll dive into which versions of Node.js support the API, the Abort API, a little later. Now let's pause for a moment and think about what benefits we can get from canceling asynchronous operations. We've said that the Abort API allows us to actually cancel them, but what benefits are there? The benefits we can expect to see are greater control over the behavior of our application. Having some kind of predictability, being able to say that, yes, we can control asynchronous operations and control when they stop as well as start, gives us a much better idea of how our applications are going to behave and makes them much more predictable. It also gives us the opportunity to free up system or network resources that the application is using if we don't need that operation to actually run. This gives us the ability to fail fast. If, for example, we have multiple asynchronous operations which are happening, say multiple HTTP requests, and one of them fails, it gives us the ability to actually cancel all the other requests if we need all of them to succeed. It also gives us the potential to improve our application performance. Now we'll apply an abort signal to making an HTTP request. You'll see again that we're using node fetch, and we are passing in an abort signal. We're not awaiting this promise because we're actually going to create a promise chain, and then we want to abort the request immediately. Here's the promise chain where we're doing the similar things that we saw in the earlier code, where we're passing the JSON response. In this case, we're logging it out if it's successful. Otherwise, we're catching an error and logging that to the console. And now after that promise chain, we're immediately aborting the request. If we run that code, we'll see that we end up logging an abort error to the console. And that is the rejected promise from the fetch function, because we passed in that abort signal and then immediately aborted it by calling the controller abort method. So let's see if we can apply it in our menu service. Things are looking a little bit different here in the menu service. We're importing the promise version of set timeout, which behaves quite differently to the set timeout you're probably used to. We'll see how we apply that in just a moment in our new timeout method. Now, inside of our menu endpoint, we've got cancel timeout and cancel request. Those are our two abort controllers, which we're going to use in this code. And skipping down a little way to where we actually make the HTTP request. This time, we're still using promise.race, but we're calling make request and this new timeout function. And this is a properly async function. It's actually using the set timeout, which is promise version of set timeout. And what this does is this delays the code from running for a specific amount of time that we specify. And so it allows us to specify this delay. We're not returning any value or resolving this promise with any value because we don't need one here. We are, however, passing in the cancel timeout signal. And then if this delay is completed, we will then cancel the request with this abort method. In make request, that's changed a little bit as well. And we're passing in a cancel request signal and passing the data. And if that request has successfully run, we will then finally cancel the timeout. And the way this works then is that with the promise.race, whichever one of these two promises resolves or rejects first, will cancel the other. So if the request completes first, it is canceling the timeout. And if the timeout is completed first, it will then cancel the request and then throw this error, meaning that this promise in promise.race will reject with an error. Now we're going to run that new service, the v3, and we're going to fire a few requests at it again. And then we'll take a look at the load testing results and see what that's done for us. So we can see now we've got similar kind of behavior to v2, where we have requests being cancelled after 1 second. The faster ones, this one in 127 milliseconds, has come back through and we've been able to pass it on with all those delicious ice cream flavors. So similar kind of behavior on the surface. Let's take a look at what happens when we put it under some load. So again, similar to v2, we've got just under one second response time. And then we've got around 100 requests per second going through. And most of the requests are failing, but that's intentional because the benefit we get is having this predictability of controlling how menu service is behaving, despite the fact that the downstream stock service is having problems. And we can see here that CPU usage is now a lot more consistent. And we've managed to reduce the number of handles, so the underlying IO operations, considerably, back down to 200, which is still fairly high, but we'd expect that for this kind of load. And also, given the fact that these requests are still taking a considerable amount of time, and there's other work to be done. So there are some next steps here. The changes we've made have improved things, but most of the time, the requests fail early. So there's more work to do to fix Ice Cream Corp's problems. We could be capturing metrics of how many requests we're aborting. We could also be backing off making requests to the stock service. And really, we need to convince Ice Cream Corp to prioritize improving the stock service. But we can do that by showing them the data of what's happening and how many requests we're aborting and what impact that has on the user experience. But that's something for another talk. Now that we've learned about the Abort API, let's take a look at the support in Node.js. So in terms of compatibility in Node.js versions, there has been stable support since v15.4 in Node.js. So that means that all v16 releases of Node.js have access to AbortController and AbortSignal classes. And there are also an increasing number of Node.js core API methods that now accept an abort signal instance as an option. We'll look at those core API methods in just a moment. And it's worth mentioning that the v16 release line enters active long-term support on the 26th of October, so just a week away at the moment. And so this makes it suitable for use in production. Now, if you're using v14 greater or equal to 14.17.0, you can enable the abort classes with an experimental flag. However, if you're running Node 14 in production, you probably won't want to use an experimental flag. So I'd recommend that you install the AbortController package and import that instead. And it's worth noting that the AbortController implementation in Node.js was very closely modeled on this package. If you're using an older version of Node.js, you can import the AbortController package, but you just won't get the benefit of core support for abort signals. You'll need to rely on the libraries that you're using supporting abort signal. And this carries us on to support for abort signal and the core methods. So there are a number of core methods in Node.js which already have support, thanks to the fantastic Node.js contributors. And then when it comes to libraries with support for abort signal, looking at HTTP libraries, I found that Node Fetch and Dici and Axios all have support for abort signal, Axios very recently. And as abort signal is not just for HTTP requests, there are other libraries that I've been made aware of that also support abort signal. So Pacina, AWS SDK, and Dockerode. I'd like to thank a few people for inspiring this talk and for their fantastic review and feedback. It's been really wonderful. And I'd like to thank you for watching. You can grab all the slides and code on my website. I'd love to hear from you, so feel free to drop me a message on Twitter. And if you'd like to talk about working together, you can get in touch through my website. Thank you very much.
Thanks ever so much for that, Simon. And it was a great talk, and it's lovely to see ice cream being represented at NodeConf as well. My daughter was very excited when she overheard that being talked about.
Excellent.
I've got a few questions for you. Just to encourage people, if you have any questions for Simon, please do put them in the chat. I'm quite happy to ask them for you. I'm going to start with, can we really start using AbortController in our Node.js applications today?
Yeah, for sure. So just to recap, Node.js v16 release line is going into active LTS at the end of next week, or actually middle of next week. So if you're looking to use Node.js v16, you get the full amount of support there. If you're using an earlier version such as Node.js 14, you probably want to use the AbortController package. If it's Node 14, you will get the benefits of the core APIs which support it. And for older versions, it's just the benefit of being able to use libraries that support abort signal.
Okay, that's great. Thank you ever so much. So I've got a question here from, I apologize for pronouncing your name incorrectly, Mbuka. So how do we update packages that we maintain to support AbortController?
That's a great question. So in terms of implementation, it really depends on whether your package needs to support older versions of Node.js. So you will want to be listening on the actual abort signal that comes into the method. I'm planning to write an article about that very soon, because I think it is going to be a common pattern that people are going to want to adapt in libraries. And hopefully it's something we'll see a lot more of. So yeah, I'd love to be writing about that soon.
Brilliant. And you'll tweet about it when you've got that article out, won't you?
Absolutely, yeah.
Yeah, just another reason to follow you on Twitter. Are there any plans for adding abort signal to support more Node.js and core APIs?
I'm not aware of an explicit roadmap for adding abort signal support. As you saw, it's been added to a lot of APIs already. I think it's quite likely they'll be added to other core APIs, but we'll just have to keep our eyes open and see what happens with that.
Okay, cool, thank you. Abuka has asked another question. Is there any pattern for force cancelling promises in pre-16 versions of Node?
That's a great question. So in pre-16 versions of Node, you don't have well, if you're using v15, which you likely wouldn't be because it was only intended as a development release branch, that has support for the set timeout which is the promise version. So you can only use that in v16. So if you're talking about the kind of promise race with the cancellation using the set timeout, you'll only be able to do that in Node.js 16.
Okay, thank you. I do have a very tangential one from Hal, but there was a couple of people upvoted this as well. The circle tool for your cursor display was really, really appreciated. And they were just saying, what keyboard shortcut do you use to get that up? Because it looked great.
Oh, that's really good to hear. So I'm presuming it's referring to this. Is that what we're talking about? This? Oh, you can't see me share my screen anymore. Sorry. It's
no, we can see it now. Here. That's brilliant.
Oh,
yes,
can now.
That's the one.
So the way that works is you can go and toggle screencast mode in VS Code, which is super handy. I think they added it as a feature a few releases back, and that toggles it on and off.
Yeah, it was brilliant. It made it super easy to follow. So thank you ever so much for that, and a great tip for everybody else who's going to do any presentations. All that remains for me to do is to say thank you ever so much for your talks, Simon. That was really great. And yes, follow Simon on Twitter. He will be hopefully tweeting out about that article soon that will help answer some of those other questions. So